Rohit here. I've been with EPAM Systems for over 2.5 years now. Have been in this lab informatics space for close to 20 years, serving the lab informatics customers across the globe. And the sole purpose of my engagement in this particular segment has been to solve the lab operationals efficiency that exist, the challenges that exist. And what I strongly believe is the complexities of the problems that exist in this particular space, the solutions always turns out to be very simple, but conditions apply. You have to have the right strategy in place, right technology in place, and more importantly, the right execution in place, right? So if you get all those three things aligned, there's no reason why any problem, complex or simpler, can be solved. So with that context, let me move forward and just introduce EPAM Systems. EPAM Systems is the place where engineering DNA does meet innovation. And we are a company which is absolutely focused on digital transformations, leveraging the latest technology trends, be it AI, be it data, be it any of the modern technology stacks that we want to incorporate in order to solve complex problems of the labs. EPAM comprises of more than 62,000 employees across the globe, and we have been serving across 55 countries, and the customer segment spreads across the globe. Not going into the details around the metrics, but since 2019, we have been operating at a 16% CAGR. It's a New York Stock Exchange listed company, and the sole engagement that thrives within EPAM for every single EPAMer is solving the problems of the customers, right? So in that context, what we want to do today is we want to just introduce you to one of the accelerators that was built by EPAM in collaboration with Elemental Machines, and we call it the EPAM Lab IoT Integrator. It's basically, it allows smart labs with real-time monitoring, providing insights, and the most importantly, seamless integration with LIMS systems within the landscape. Now, just imagine a situation, we have a state-of-the-art drug discovery lab, right? And maybe some high-throughput assay executions are going on, maybe related to CAR T cells, right? And one can imagine the importance that relies on ensuring that any of the molecules, for example, or the reagents which might be in use as part of the assay execution, they need to be in a certain in an optimal storage condition, right? Now think of it like things do not go as per plan, and you end up executing an assay using a molecule or a reagent which was under suboptimal storage conditions. And at the end of the assay execution, you come to know that these things did not go right, right? So we are talking about data capture, we are talking about AIs, we are talking about being able to capture all that data and report, but it's all after the fact, right? So when the things have already been executed, you come to know that things did not go right as per plan. Now the idea is we have solutions in market which kind of captures all those real-time information. The only gap that exists is those informations are not getting translated during the runtime execution of the assays. Or in other words, our LIMS systems or the lab processes, when they are getting executed, they are not aware of the discrepancy that has happened. So it would make sense to have those information be available right upfront instead of waiting for the entire assay execution to complete, and then in the audits we find that things did not go as planned, right? So in order to solve that, I think there was one question around partnerships. Yes, EPAM engages very strongly with technology capabilities enablers, and Elemental Machines was one of the technology platforms or companies that we collaborated with. For those who don't know, Elemental Machines is an IoT cloud platform. They have their own suite IoT devices which are used in the labs to monitor different environmental monitoring parameters, right? So they do a wonderful job in combining the physical and the digital world. And their IoT devices are Bluetooth enabled, which is very easy to install on the instruments across the labs. So we took it as a real scenario wherein we would want the data which these devices are capturing from the different instruments, and the type of data which is getting captured, be it with respect to the humidity, the temperatures, the carbon dioxide levels, the oxygen level, the pressure. It could be any of the environmental monitoring data that they are capturing. They are all being captured and being stored in the IoT cloud platform, which is great. But the thing is, that information, they are also sending out notifications to the users that, you know what, something has gone wrong, some notifications, some out of range stuff has happened, which all sounds good. But the thing is, you need to act on those notifications as well. And when we say we need to act, it's not just about for the individuals or the lab users to act on those notifications which is generated by Elemental Machines. Rather, why not have the LIMS applications or the ELN, which is actually driving the assay execution within the labs, be fully aware of the discrepancy that has happened, and stop the lab users or the processes to execute further just because it's aware that something has not gone right? So in order to kind of fill that particular gap that exists, the data is getting captured, nice and beautiful. We have a LIMS application running in the lab, which is great, but they both need to talk, right? So that's where EPAM came up with this Lab Informatics Accelerator, which we call it as the Lab IoT Integrator. The key thing about this particular integrator is it's a fully configurable accelerator which actually solves 3 problems right at one shot. Number one, it eliminates the need to implement point-to-point integrations of any LIMS application with any other IoT devices. You don't need to have, let's say you have more than 3 LIMS applications running in your lab. Apparently, you don't need to make 3 point-to-point integrations to get this particular IoT device's data being ingested by LIMS. The second thing is, the entire business requirements, we would want it to be configurable, to be something which can be done by the lab users, not by technical people, to set up this particular integration. We would want it to be as user-friendly possible, right? So with those 2 aspects, and the third one, most importantly, we want it to be a real runtime monitoring capability. Nothing should happen after the fact. It should be something that gets trapped during the execution of the assay execution itself, right? So with this context, this particular IoT integrator was built. Taking a little bit more deep dive into it, what we found that the application of this particular accelerator spreads across the R&D labs, the biotech pharmaceutical labs, the environmental monitoring labs, the food and beverages, clinical labs, manufacturing QC labs, any labs, to be very honest, right? And the 6 levers, which is kind of enabling this particular solutions are, we want to have the advanced workflow automation in place. We would really want the data, the information, the incidents that occur due to environmental slippage, that should kind of be monitored at every stage of the workflow process. We would want to get into the end-to-end lifecycle management, right? So we do not want the audit reports to get generated at the end of the assay execution only to tell that, you know what, something did not go right. Rather, we would want exactly at what point of time during the assay execution things went off, and we would want to stop there right away. We want to stop wastage of time, money, energy, all those aspects. The biggest challenge that we had is we wanted to make it vendor agnostic from a LIMS application perspective. So this particular accelerator does allow Elemental Machines data to be sent not only to one LIMS, but any LIMS application that might be at play in your landscape. Only constraints apply. It should be REST API enabled. All right. Moving on, looking at a little bit deeper into the technology stack, it's based on open source technology. It gives a jump start to all your integration applications needs, right? You don't need to start building an integration right from scratch. So the turnaround time for implementing any integrations with IoT platform with your LIMS application, you're not going to spend that much amount of time, money, and energy, right? It's all about configuring this particular accelerator. So it's based on open source technology stack. It's a web-based application. You have an Nginx server, which is accepting all the web requests. You have a Unicorn application server, which is taking care of all the Python-based scripting. So any of the configurations which is done, it can be supported further through Python scripts. And The entire thing is hosted on an EC2 instance, so we have an integration layer which gives you all the configuration user interface to configure this particular accelerator. It is, as I mentioned earlier, it is REST API enabled, so all the communication that happens in terms of fetching data from elemental machines, or for that matter, triggering information into LIMS application, it's all via REST API. Let's spend 2 minutes trying to understand how does it work internally. What's the magic going on? There's no rocket science involved. As I said, the solutions to problems need not be complex. The problems can be complex, but the solutions can be really simple. And what you are seeing out here is a real simple implementation of this particular solution. So what we have is, as part of, on the left-hand side, you can see you have your elemental machines, which is capturing all the IoT monitoring data through the IoT devices. And on the right side, you have your LIMS applications, right? Now, what we are doing is, this particular IoT integrator, it has the ability for you to define event rules. So you can say that, you know what, start monitoring this particular IoT device for a temperature fluctuations, which should not be more than 2 degrees Celsius. And even if it happens, it should not be more than, let's say, 10 minutes. So these kind of event rules can be defined or configured within this particular accelerator integrator. Once you have those event rules defined, you can actually go ahead and define the frequency at which you would want to monitor these particular event rules. Should it be monitored every 5 seconds, 10 seconds, 15 seconds, 1 minute? That's all configurable. Now, once you define that, that's when the integrator actually starts monitoring the IoT devices. As part of your configuration, you are also actually defining what happens when an incident happens. Based on that event rule, certain incident happens. It allows you to actually define the event processor as well, like what it should do. Should it go to LIMS and make a Kappa incident? Or should it mark a batch as having some discrepancy? Should it mark certain samples as disposed? Should it mark certain reagents as not ready for use for a particular assay execution? Whatever is the business logic that is required, all those things you are either configuring or writing Python scripts within the integrator to define those business logics, right? Now, the fun part of it is the last section on the bottom right. There would be use cases wherein you don't know upfront what event rules to define. The event rules are defined by the LIMS application's actual transaction data. So as part of the assay execution, the information of which resides within the LIMS, LIMS would be able to be aware of that, you know what, as part of this assay execution, it's mandatory that the storage condition should be this. The environmental humidity factor should be this. So this information is there with LIMS. So this is the beauty that happens. LIMS would be able to make an API call and define that event rules on the fly without requiring any human intervention. It would be able to define the event rule, it would be able to define the frequency, and as soon as it's defined, it will keep working, and then based on whatever you are asking it to process, it will do the subsequent actions downstream. Now, so we have the IoT applications, we have the LIMS, they are communicated, they are connected. Now, this is where we are bringing in the power of EPAM's other AI-based solutions, right? So we would not want this particular integrator to be limited to configurations. We would want that particular integrator that we can leverage AI as well. So this is where we are proposing introducing two AI solutions of EPAM. One is the EPAM's GenAI that we call as our digital assistant. And then we also have EPAM's AI Dial platform, which is basically an orchestrator which allows you to leverage any of the LLMs that exist in the market. Using the power of both these, we can actually take this particular lab operations to the conversational AI aspect. So now you can not only define those event rules that we were talking about through configuration, you can actually define those event rules even through your straight, simple language using NLPs and whatnot. So that kind of expands the capability or the possibilities that we can leverage in the lab space by leveraging all these three components of EPAM. EPAM's GenAI, EPAM's Dial AI, and EPAM's Lab IoT Integrator.